Hi friends, in this video we are going to look at one of the most underrated parts of an aircraft. We will talk about what its wheels are filled with, why nitrogen is used, what loads the tire survives when it hits the runway, and how an ordinary wheel can become a safety issue for the entire flight. If the topic grabs you, support the video with a like and write in the comments whether you knew this before. What are aircraft wheels really filled with? Air. That is what almost everyone thinks. But on large passenger aircraft, everything is very different. Their tires are usually filled with dry nitrogen. This is not a whim or a gimmick. It is a decision that came out of hard experience. Because an aircraft wheel works in conditions where normal car logic simply does not apply. During landing, an aircraft touches the runway at roughly 250 to 280 kilometers per hour. Before touchdown, the wheel is barely rotating. After touchdown, it has to spin up to that speed in a fraction of a second. That is why you sometimes see smoke at landing. It is not there for effect. It is the rubber doing real work under enormous load. At the same time, one wheel on a large airliner can carry up to 27 tons of load. Pressure inside that tire is usually around 14 bar, and sometimes it reaches 18 bar. For comparison, a car tire is usually around 2 to 2.5 bar. Even a lorry tire usually runs at lower pressure than many aircraft tires. So an airliner tire lives in a completely different world. Huge weight, high speed, a violent hit on the runway, and beside it, red-hot brakes. This is where the key point begins. If there is ordinary air inside the tire, then there is oxygen inside it as well. And when the tire gets very hot, the materials inside it can release gases. If oxygen mixes with those gases, a dangerous mixture appears. Put simply, the wheel may not just burst, it may catch fire or even explode. That is exactly why American aviation rules for large aircraft clearly state that these wheels must be filled with dry nitrogen or another inert gas. Nitrogen is there to remove oxygen and reduce the risk of ignition inside the tire. That is the whole point. Aviation does not want to rely on luck. It wants to remove extra risk before the flight even begins. And if you look at it honestly, the question of what aircraft wheels are filled with turns out to be far more interesting than it sounds. Because underneath an aircraft, there are no ordinary little details. Even a wheel is a complex part that has to survive impact, speed, heat, and weight while remaining invisible to the passenger. If the wheel is doing its job properly, nobody even thinks about it. But if it fails, problems begin at once. That is why nitrogen in an aircraft tire is not a fun quiz fact. It is a simple answer to a very serious problem. How do you stop a wheel from turning into a danger at the exact moment the aircraft touches the ground? But nitrogen does not make a wheel eternal, and it does not save it from every danger. It solves only one problem. The most common trouble for an aircraft tire comes not from inside, but from outside. It is debris on the runway. A small bolt, a piece of metal, a broken fragment of some part. Something that an ordinary driver would never even notice can turn into a knife for an aircraft moving at speed. The most famous example, of course, is Concorde. The disaster began with a metal strip about 43 centimeters long lying on the runway. The aircraft ran over it at about 324 kilometers per hour. The strip sliced the tire. A large piece of tire weighing about 4.5 kilograms broke off and slammed into the underside of the wing. Then the terrible chain began. Tank damage, fuel leak, fire. In other words, the disaster was triggered not by the engine and not by some unbelievable coincidence, but by a tire and a strip of metal on the runway. A tire on an aircraft is dangerous not only by itself, its fragments are dangerous too. When a tire breaks apart at high speed, it can strike neighboring systems, the brakes, the hydraulics, parts of the wing, and other wheels. That is why aviation takes runway cleanliness so seriously. Debris on the runway is not just debris, it is a possible accident. But there is another problem. A tire can fail not only because it was cut, it can also be killed by overheating. After a heavy landing and hard braking, the brake assembly gets extremely hot. And if the temperature rises too far, pressure inside the tire goes up. To stop the wheel from bursting, aircraft wheels have special fuse plugs. If the temperature reaches a dangerous level, the plug melts and releases the pressure. Put simply, engineers admit an unpleasant truth in advance. Sometimes the tire cannot be saved. In that case, the next best thing is to make sure it does not blow apart like a bomb. And that is very typical of aviation. Nothing is built on hope. Everything is built on a backup plan. An aircraft tire can lose part of its pressure even when there is no visible damage. That is why pressure in aviation is checked regularly, not by eye. On large aircraft, a pressure loss of more than 5% in a day is already considered a reason to investigate. If the pressure drops further, the tire may be removed from the aircraft. So there is no such thing as, well, it looks all right. Either the number is within limits or the wheel is already raising questions. Now for the most logical question. Why did aircraft use air in the past and then move toward nitrogen later on? The answer is simple. Earlier aircraft were lighter, slower, and did not put such brutal loads on their wheels. Smaller aircraft land at roughly 130 to 170 kilometers per hour. A large passenger airliner lands at around 250 to 280 kilometers per hour. The difference is huge, and it is not just about speed. The higher the speed, the more energy there is in the moment of impact. The heavier the aircraft, the greater the load on the tires. The stronger the brakes, the more heat is generated. That is exactly why a small aircraft and a big airliner are two completely different worlds, even if from the outside their wheels look similar. In smaller aviation, the loads are lower, and historically, it was simpler to use ordinary technical air. But when aircraft became heavier, faster, and hotter during landing, air started to lose to nitrogen on safety, and the industry gradually moved towards stricter rules. You cannot really compare an aircraft tire to a car tire. The closest comparison would be a lorry tire, but even that lives a calmer life. A lorry does not spin its wheel from almost 0 to 270 kilometers per hour in a fraction of a second at the moment of impact with concrete. A lorry does not come back from a flight weighing tens of tons. A lorry does not work next to red-hot aviation brakes under that kind of stress. That is why an aircraft tire runs at higher pressure, follows stricter rules, and is maintained more aggressively. Even temperature affects it more strongly than many people think. A change of only a few degrees can already change the pressure inside it. That is why you cannot simply let a little out until the number looks right when the tire is hot. Once it cools down, it will end up underinflated. And underinflation for an aircraft tire is a direct road to extra heat, heavy flexing, and faster destruction. That is why aviation hates improvisation. Everything must be by the numbers. Everything must follow procedure. Everything must be checked. An aircraft wheel looks simple only to someone who has never seen how many problems can begin with it. In reality, it is one of the most heavily loaded parts of the entire aircraft. And when the industry moved from air to nitrogen, it was not a technical upgrade for the sake of looking clever. It was a direct response to real risks, real overheating, real tire failures, and real accidents that showed the old approach no longer worked on large airliners. There is one more very important point. Aircraft tires are almost never thrown away immediately after their first wear. They are rebuilt. This is standard practice across the whole industry. The tread wears out, but if the tire casing is still in good condition, it is sent away for retreading. A bias ply tire may go through this up to 6 times. A radial tire usually up to 3 times. In total, one tire may survive around 1,400 takeoffs and landings. That is exactly why an aircraft tire is expensive. In smaller aviation, openly listed prices may begin at around $200 to $400 each. More serious models for business aviation can cost several $1,000s for a single tire. For big airliners, open prices are harder to find because that side of the industry usually works through large service contracts. But the meaning is still clear. An aircraft tire is an expensive, complex part that can be rebuilt and used again many times. It is inspected, counted, maintained, and used for as long as the casing remains safe. After that, it is either rebuilt or finally retired. And this is where the full picture comes together. What are aircraft wheels filled with? Dry nitrogen. Why? To remove oxygen and reduce the risk of ignition under heavy heat. Why does that matter? Because the wheel works under enormous pressure, at high speed, and right next to very hot brakes. What destroys it? Runway debris, overheating, pressure loss, underinflation, and heavy braking loads. Why is it watched so closely? Because one tire can carry tens of tons, and if it fails, it can trigger a whole chain of problems. What happens after it wears out? If the casing is still sound, it is rebuilt and put back into service. So an aircraft wheel is not just rubber. It is an expensive, heavily loaded, very important part that on a normal flight should remain unnoticed. The less the viewer thinks about the wheels, the better those wheels have done their job. But the deeper you look, the clearer it becomes that under an airliner, there is nothing random, nothing simple, and nothing secondary. Everything there follows one single rule: hold, work, and do not fail at the worst possible moment.